This is the second video for section 3.7, elasticity of demand. We're looking at example number 2. For the demand function Q equals d of P equals 100 over P plus 4 raised to the 4th power, we are asked to find the elasticity. Now remember the formula for elasticity function is, it was E of X, but I'll go ahead and use P because they're using P as their input variable, okay? So E of P equals negative P times derivative of the demand function divided by the original demand function. So we're going to have to do that. But in order for me to plug in everything into this formula, I need to find d prime of p. So I noticed that d of p is a quotient. It's 100 divided by p plus 4 to the 4th power. I don't want to use quotient rule. So I'm going to rewrite this d of p. I'm going to rewrite this so that it looks like 100 times p plus 4 to the what power? Negative 4th power. That's how I can get this bottom of the fraction out. It's not in the bottom anymore by changing that positive 4, that original exponent, to negative 4. If I have it this way, I don't have to use the quotient rule. I can just use the chain rule. Multiply 100 by negative 4. The new coefficient is negative 400. And I will get p plus 4 raised to the negative 5th power because I need to go down 1 from the original exponent. Technically, I need to multiply this by the derivative of the inside part, right? But derivative of the inside part will just be 1 because this will just be 1. So I don't really have to write down times 1. But if it was anything other than p plus the constant, if it was like 2p or 3p, then you have to remember to use the chain rule. All right, this looks like negative 400 on top. And in the bottom of the fraction, I have p plus 4 to the, and let me go put that positive 5 as the exponent because I sent it to the bottom. So we have the d prime of p. So I have everything I need to find the elasticity. So here I go. I will have negative p times, all right, what I'm doing is I'm writing down this numerator first, okay? Negative p times d prime of p, negative 400 times p plus 4 to the 5th power. But I have to divide, all right, by the way, this is the green part, right? But now I have to divide this by d of p. I'm dividing this by this fraction. So instead of dividing a fraction, let me go ahead and do keep change flip. Instead of dividing, let me say I'm going to multiply by its reciprocal. I will flip this. Okay, I will flip and get p plus 4 to the 4th power on top and 100 in the bottom of the fraction because that's how you divide fractions. You keep change flip it. Okay, let me simplify this then. On top of the fraction, it looks like I'm going to have negative 4 times. All right, hold on. Let me circle these. All these are going to be on top of the fraction, right? 400p times p plus 4 to the 4th power. And it became positive because we're doing negative times negative. And in the bottom of the fraction, let me just combine these two, or put these two next to each other. 100 first. 100 first. And then I have p plus 4 to the 5th power. And we can simplify this further. I can divide 400 by 100, and the top of the fraction will have 4p. But look, the denominator, look at this part. I have p plus 4 to the 4th power dividing by p plus 4 to the 5th power. So I can simplify this as p plus 4 to the 1st power. So this is the elasticity for this demand function, okay? Now what? They want us to find the elasticity at p equals $6. So let's find E of 6. What will happen if I plug in 6 into this formula? All right, let's see. 4 times 6 divided by 6 plus 4. That is 24 divided by 10. And this is definitely greater than 1. So what does that mean? They want us to state, oh, where was I? So it came out to be greater than 1, which means the demand is elastic. Whenever it is greater than 1, you say it is elastic. And what that means is a small rise in price. If it becomes any more expensive than this, it will actually decrease the total revenue. Okay? All right, how about it says the value of P for which the total revenue is maximized. Oh, they want us to find unit elasticity. So how do you find this? You'd find this by setting E of X, or E of P in this case, equal to 0. When elasticity is equal to 1, the total revenue is maximized. So I need to set that function equal to 1. So I say 1 equals, okay, I can't write 1 for some reason, 1 equals 4p divided by p plus 4. I'm going to multiply both sides by p plus 4. Well, for a fraction to be 1, the top and the bottom has to be equal to each other, right? For a fraction to be 1, it needs to be 4p equals p plus 4. So I'll write that. P plus 4, I'll just say 4p must equal to p plus 4. If I subtract p from both sides, I will get 3p equals 4. And if I divide both sides by 3, I will get p equals, it's going to be a nice number. Not really. Hold on. 4 divided by 3. I think it's $1.33-ish. Where are you, calculator? Oh, here it is. 4 divided by 3. The unit elasticity will be achieved at $1.33. $1.33. So the total revenue will be maximized when the price of this item, we don't know what it is $1.33. They shouldn't make it any more cheaper or any more expensive than that. Okay, I think I can finish this in this second example. This will be the shortest lesson of this semester, really, right? For the demand function, Q equals D of X equals 500 over X. They want us to find the following. First, find the elasticity. Well, the elasticity function, I think I may have copied the formula down from the first page, is this. So in order to find that elasticity, you need to find d prime of x. D of x is 500 divided by x. So I'll rewrite this as 500 times x to the negative first power. That is how I got this bottom of the fraction x out of it. So x to the negative first power. Then what is d prime of x? That is negative 500 times x to the negative second power. I can write this back in a fraction format. Negative 500 over x to the positive second power. So I have all my pieces. I just need to plug them in. So here is my e of x. The green part. I'll write this first, okay? Whenever I divide fraction by fraction, I just do keep change flip. So I will have my negative x times negative 500 over x squared. Okay, this is this piece right there. But I'll divide this by d of x, which means I will change it to multiplication, and I will just flip the second fraction and make it x over 500. Okay, and then I simplify this. So what's on top of the fraction? I will have negative x times negative 500 times x. That will be positive 500x squared. And in the bottom of the fraction, I will have 500. Oh, what's going on? 500x squared. So what is this? This is super cool. This is equal to just 1. Anything divided by itself is just 1. So e of x is simply 1. This is very, very interesting. So if they ask you to find the elasticity at x equals 6, well, price is 6. Already the maximum is achieved. When you plug in x equals 6 into a constant function 1, it will come out to be 1. So it is unit elasticity. If it's equal to 1, then we have unit elasticity. And so the values of x for which the total revenue is maximum. But when the elasticity is 1, no matter what the value of the price is, well, what we just have to say is I guess, the total revenue is independent of the price X, the price doesn't matter. The total revenue is maximized no matter how expensive or how cheap this price is. But that is how you can do this very last example. You have about 10 questions on this homework, 3.7, I believe. I can check that real quick. Oh, well, I'll stop this video now.